Hello guys, now we're gonna do problem 9.23. It says a flywheel with a radius of 0.300 meters starts from rest and accelerates with a constant angular acceleration of 0.800 radians per second square. We have to, the first part, it says that we have to compute the magnitude of the tangential acceleration, the radial acceleration, and the resultant acceleration of a point on its rim. We're gonna start, I guess, the angle 0. And something important that we can take from this is that the tangential acceleration, it's gonna be the same throughout the whole process, because the formula is the tangential acceleration is equals to the radius times the constant angular acceleration, which they're not going to change throughout the whole process. So if we want to calculate that, we find that it's going to be 0.24 meters per second square, and that's going to be the tangential acceleration. And to find the radial acceleration, the formula is angular velocity squared times the radius. When starting from rest, we know that the angular velocity is 0, so this whole thing goes to 0. And now to find the resultant acceleration, we use Pythagoras. We're gonna take the square root of tangential acceleration square plus the radial acceleration square, and it's right here. So since this is 0, we just cancel out and we just square it and square root it, so it's gonna cancel out, and the resultant acceleration is gonna be the exact same as the tangential acceleration at the start, the first point. So now we're gonna find all this, but for different angles. First is gonna be through a 60-degree angle, and the first thing to do is to convert the 60-degree angle to radians. And to do that, you have to multiply times pi divided by 180. We get pi over 3. And then using the kinematics, we take these two formulas and all right, so now we're gonna do it through the 60-degree angle. And the first thing to do is, since we're working with radians, is to convert it. And to do that, you just multiply the angle, the degrees, times pi divided by 180 degrees to get rid of the degrees, and we get radians. And now from the kinematics, we use this formula to find the angular velocity, which is exactly what we need for the radial acceleration. These two go to 0, and we can simplify the formula, and the angular velocity square can be substituted in this formula. And now, as you can see, the only thing different, we just add the radius, and if we multiply that, we finally get the radial acceleration, which is 0.503 meters per second square. And then and like I said before, the angular the tangential acceleration is going to be the same. So now we just find the resultant acceleration, which is going to be the square root of both of the acceleration, the tangential and the radial, and we get 0.557 meters per second square. Now lastly, we're gonna do the same with the degree of 120. We do the same, we multiply this and we get this radians. And like I said before, we're gonna substitute all this. We're gonna substitute this into here, and we get this formula. And if we start plugging in numbers, we're gonna do 2 times the radial acceleration, which is 0.800 times the radius. The radians is gonna be pi over 2 pi over 3 times the radius, which is 0.3. And then we get, put in the calculator, 2 times point. We get 1. And now to find the resultant acceleration, like I said before, is going to be the square root of those two. The first one was the tangential acceleration is going to be 0.24 square plus 1 square, which is the radial acceleration in this case. Then we get 1.03 approximately. So that's the resultant acceleration. And it's gonna be meters per second square. Thank you.